Hello, and welcome to today's HCPA training course. In today's course, I will introduce to you the Huawei G-Series heterogeneous servers. Today's course includes 4 parts. First, let's look at the development trends and market situation of heterogeneous computing. If we look back on computing trends over the previous several decades, we'll notice an interesting phenomenon. That is, the popularization and application of new technologies has always caused computing power gaps between demand and the actual level that can be achieved, and these kind of challenges have driven the occurrence of new computational chips to be able to make computing capabilities leap forward. In the current market, it's AI and big video that are posing the current challenges and driving computational capabilities. Heterogeneous computing mainly refers to the use of different types of instruction sets and architectures in the computing units for systems calculation. General heterogeneous computing architectures include CPU plus GPU, or FPGA, and ASIC. Common computing unit categories include CPUs, GPUs, DSPs, ASICs, FPGAs, and more. The computing development process has gone from single-core to multi-core to heterogeneous computing, and perhaps the popularization of resource pooling architectures in the future. The architecture designs of heterogeneous computing units are quite different from x86 CPUs, which are good at general-purpose computing. Usually, heterogeneous chips have thousands of computing cores and good paralleling compute capabilities. These advantages really provide a lot of benefits to improve computational efficiency. Speaking about details of GPU, FPGA, and ASIC, all of them have some particular advantages and features on the computational side. So that means we need to choose a heterogeneous computing mode that's best for us based on our specific application scenario. This slide talks about the fast development of deep learning and the democratization of HPC accelerating heterogeneous computing. Deep learning, that is to say deep neural networks, are suitable to be accelerated by heterogeneous computing or GPUs, so heterogeneous computing is widely used in the visual design and speech recognition scenarios. Right now we can see more and more applications being accelerated by heterogeneous computing. On the other hand, in the HPC domain, we can see more and more GPU-accelerated supercomputers emerging in the top 500 HPC list over the recent years. Now let's move on to the Huawei G-Series heterogeneous servers. Huawei G-Series heterogeneous computing platforms are the product portfolio of Huawei's new generation heterogeneous servers, including the G5500, a data center-oriented heterogeneous server, and the G2500, a smart video analytics server, which is used in scenarios such as AI training, AI interface, HPC, and cloud services. The G5500, a 4U modular server system, can be flexibly equipped with a full-width node G560 or 2 half-width nodes G530 V2. As a combination of heterogeneous computing modules and general computing modules, both the server nodes support 2 CPUs and multiple GPUs. On the other hand, server nodes can also share key components and system resources, such as PSUs, fan modules, and I/O modules, installed in the G5500 chassis. G560 can accommodate 8 FHFL heterogeneous accelerators, such as the NVIDIA Tesla V100, P100, or P40, and 2 Intel Xeon E5 2600 V4 series processors, each supporting 4 DDR4 DIMMs. Regarding local storage, G560 can support up to 6 2.5-inch NVMe SSDs and 2 2.5-inch SAS or SATA hard drives, and 8 3.5-inch SAS or SATA hard drives. G560 includes 2 mechanical modules. One is to accommodate CPUs and DIMMs, and the other is for multiple GPUs. G530 V2 supports up to 16 NVIDIA Tesla P4 GPUs and 2 Intel Scalable processors. Similar to G560, G530 V2 is a combination of general-purpose computing modules and heterogeneous computing. However, the G530 V2 supports only 2 2.5-inch hard drives because it needs to accommodate high-density GPU accelerator cards. The G5500 provides shared PSUs, fan modules, I/O modules, and management modules at the rear of the chassis. The maximum power consumption of the G5500 is 2200 watts. It supports 4 titanium PSUs, which support N+N redundancy. Its 6 hot-swappable fan modules support N+1 redundancy. In addition, G5500 provides 4 PCIe x16 slots for flexible I/O capacity expansion. Compared with traditional products, G5500 has 3 main advantages: superior heterogeneous computing performance, one-click switching of heterogeneous topologies, and a fully modular design. G5500 supports the GPU Direct technology, which enables efficient multi-GPU interconnection and maximizes computing performance. By limiting unnecessary CPU processing time, the NVIDIA GPU Direct technology enables the GPU to communicate with other devices on the PCIe bus faster. GPU Direct version 1.0 allows third-party device drivers, such as drivers for InfiniBand adapters, to communicate directly with the CUDA driver, eliminating the processing time that would be needed for replicating data on the CPU. GPU Direct version 2.0 allows multiple GPUs in the same system to implement peer-to-peer communication, avoiding extra CPU processing time. G560 supports one-click switching between Topology 1 and Topology 2 so that different AI or HPC workloads can be flexibly supported. Topology 1 is a cascade structure, where multiple GPUs are used to provide powerful parallel computing capabilities. Therefore, 8 GPUs are connected to the same CPU, and the CPU to GPU ratio is 1 to 8, which is suitable for AI training. Topology 2 is a balance type. Every 4 GPUs are connected to one CPU, and the CPU to GPU ratio is 1 to 4. In this way, multiple GPUs can be aggregated to provide computing, while the CPU and GPU can directly interact with each other. This topology applies to scenarios such as HPC and AI intelligent cloud acceleration. The G560 full-width node supports one-click topology switching, while the G530 V2 uses the balanced mode to mount 16 NVIDIA Tesla P4 cards to 2 CPUs to provide online and real-time decision results for the AI interface. The G5500 supports a fully modular design. The hard drives, fan modules, and PSUs support hot swapping and maintenance without opening the chassis cover. The CPU, memory, RAID, GPU, and I/O cards can be flexibly replaced on-site. The general-purpose computing module and heterogeneous computing module are structurally decoupled and support independent, long-term, cross-generation evolution, protecting customers' investment in hardware. Compared with traditional GPU servers, G5500 can effectively simplify O&M. Thanks to its fully modular design, G5500 can implement online maintenance by one person without opening the chassis. Traditional products have used an integrated hardware architecture design. If key components such as CPUs and GPUs need to be replaced for maintenance, they need to be removed from the rack, which can require at least twice the time and labor of the G5500. Huawei Fusion Server G2500 is an intelligent video analytics server oriented to heterogeneous computing. In addition to providing high-performance general-purpose computing capabilities, G2500 supports heterogeneous processors, such as GPUs, and provides large-capacity local storage. What's more, G2500 features flexible configuration, a compact size, strong environment adaptability, easy maintenance and management, and can run in a wide temperature range. Currently, it is mainly used in intelligent video surveillance, analysis, and data storage scenarios. It can be widely deployed in various edge and central equipment rooms, meeting the requirements for intelligent surveillance in areas such as campuses, enterprises, metro areas, transportation, and public security applications. The G2500 Intelligent Video Analytics Server uses a 4U chassis that supports 16 NVIDIA Tesla P4 accelerator cards and 2 Intel Xeon E5 2600V4 processors. It can be configured with 12 DDR4 DIMMs and 24 3.5-inch hard drives. G2500 provides 4 fan modules and 4 titanium PSUs, supports N+N redundancy, a maximum power consumption of 2,450 watts, and provides 4 GE electrical ports and 2 10 gigabit Ethernet optical ports. Fusion Server G2500 has 3 outstanding features listed on this slide. First is its robust intelligence. A 4U chassis supports 16 half-height, half-length heterogeneous accelerator cards, such as GPU, MIC, and FPGA, meeting the requirements of 256-channel HD video stream analysis and inference. It also has an ultra-large storage capacity, with support for 24 3.5-inch hard drives with up to 240 terabytes of local storage capacity, meeting the long-term storage requirements of multi-channel video streams. And it is best suited for edge computing. Refined air ducts and a unique heatsink design ensure that servers can run stably at temperatures between -5 and 55 degrees Celsius. The triple system anti-vibration design ensures long-term reliability of the entire system and local hard drives, meeting requirements in harsh working environments in edge computing scenarios. Next, let's take a look at the application scenarios and typical configurations for heterogeneous servers. Fusion Server G5500 is mainly used on the data center side to support AI training, inference, and HPC applications. It is applicable to model training for massive datasets, structured data and query of images, speech, and videos, and large-scale clusters. Server G2500 is used for inference on the branch side in edge computing scenarios, including identification, inference, online problem solving, unstructured data processing, and real-time precise answering. To meet customer requirements, Huawei plans to launch a more compact intelligence server for deployment closer to the terminal side. A typical application for G-series heterogeneous servers is smart video analytics. As an example, let's look at the Safe City Video Surveillance solution for the Municipal Public Security Bureau. This solution has the following highlights: 10,000 channel level large-scale video analysis with separated cloud-based storage and computing, structured video retrieval and sample recognition, image search, face and license plate recognition, and tracking analysis, deep learning and training during video identification. They'll be able to connect to edge smart analytics appliances, exporting image information to the central platform, and network-wide intelligence analysis. Additionally, we can also look at the traffic surveillance scenario, which has the following highlights: analysis storage appliances with 100 to 120 channels for common sites, 120 to 140 channels for interchange stations, and the ability to store high-definition video for up to 90 days. And a wider range of service models, including face snapshots, modeling and import, facial feature comparison, facial retrieval, tracking display, facial retrieval, tracking display, flow statistics, driving backwards, crowd density, tripwire and intrusion detection, detention and suspicious abandoned object detection, passenger chasing, and sharp vibration monitoring. Another typical application for G-series heterogeneous servers is artificial intelligence. Artificial intelligence consists of image recognition, speech recognition, natural language processing, machine learning, and other types. Artificial intelligence is applicable to industries such as retail, healthcare, agriculture, industry, and finance. HPC is also a main scenario for G-series heterogeneous servers. HPC application servers include CAE simulations, physics, chemistry, life sciences, meteorological environmental science, oil exploration, and animation rendering. It is mainly used in scientific research, weather forecast, computing simulation, CFD or CAE, biopharmaceuticals, gene sequencing, and image processing. GPU Acceleration Cloud Server is applied to deep learning, graphics database, high-performance databases, computational fluid dynamics, computing finance, seismic analysis, as well as molecular and genomic modeling. FPGA Acceleration Cloud Server is positioned for the high-density computing, high concurrency, and high bandwidth fields. It is usually applied to video processing, machine learning, genomics research, and financial risk analysis. Finally, in the last part of today's course, let's take a look at some successful case studies. HSBC wanted to build a facial recognition access control system that supports 32 cameras. Constrained by equipment room space, HSBC needed an integrated system which supports smooth upgrade. Huawei presented an intelligent facial analytics solution that runs on the Huawei G2500 server and leverages state-of-the-art facial recognition algorithms to support over 200 cameras for real-time facial recognition. Based on Huawei's G2500 video analytics server and the SenseTime facial analysis software, the Intelligent Facial Analysis solution provides customers with small and medium-scale integrated back-end solutions, covering public security, shopping malls, transportation hubs, enterprise campuses, and community parks. It supports intelligent video analysis functions such as dynamic facial surveillance, static facial comparison, and historic track restoration. Huawei Cloud builds FPGA Intelligent Cloud Acceleration and GPU Resource Pool services based on the G5500. Currently, the services that have been launched include the P1 GPU Accelerated Cloud Service for numeric computing, PL1 GPU Accelerated Cloud Service for inference, and the FPGA-based FP1 Accelerated Cloud Service. Huawei helped Shanghai University of Science and Technology to carry out three-dimensional reconstruction of electron microscope imagery. Huawei provides high-performance hybrid computing clusters based on Intel x86 architecture and GPU high-performance servers. The double precision theory peak reaches 355.4 teraflops. G5500 servers with NVIDIA GPUs deliver double precision computing peaks of 235 teraflops or single precision computing peaks of 368 teraflops. That's all for today's course. Thank you so much for your time. Have a great day.